Hey everyone, Chris Terry here, creator of Personica AI and founder of Swamp Rabbit Labs, and welcome to the first part of our video tutorial series for Personica AI. This series is going to walk you through how to use Personica step by step and go over all of the unique LLM integration and data framework configuration options that Personica gives you. This is part one of the series, and in this video today we'll be going over the very basics, so how to add Personica as a plugin, how to get started, and some of the initial settings that you need to be familiar with. In subsequent episodes we'll get further into the data assets and into setting up your individual character specific configurations. Now, as a quick disclaimer, this video series is being made with the 0.9.3 version of Personica AI, so there might be some functionality that looks different to you depending on which version of Personica you are using. We'll keep updating these videos as more updates are made to Personica, especially as we approach a stable version 1.0 release. Otherwise, please keep an eye on our website support center for up-to-date documentation and to help assist with any of the differences that you might see between this video and a later version of Personica. If you do have any questions, comments, or concerns, please get in touch with us at contact@swamprabbitlabs.com. So without further ado, let's hop into Unreal Engine and get started. Okay, so we're here in Unreal Engine. Now, if you've purchased Personica AI, you'll be able to install Personica in your Epic Games launcher and in the Unreal Engine launcher. To just verify that the plugin's actually been installed, you'll head to Edit and then Plugins, and you can search for Personica directly there. You'll also get a link to our website directly if you want to follow along with the written documentation as well. Now that I'm in my project here, so we've spun up just the default first-person Unreal Engine project, what I want to go over first are the specific project settings that you need to be aware of. Then we'll get into really quickly how to add a brain component to a character and take a quick look at what that character-specific menu looks like. And then we'll move into maybe some of the more advanced data asset builds for those options in subsequent videos. But to take a look at our project settings, so Personica operates both on the project and the character level. So you can have different settings for the overall project and different settings for each individual character. Now, some settings are very much project specific, some can be character specific as well. Something important to keep in mind, anywhere that you see overlap, where the project settings has one option and the character setup has the same or a similar sounding option, it's usually the case that the project settings will be used as a global default for all characters, but that the character specific setting will override that default. So quickly jumping in here, we've opened our project settings for Personica AI. At the very top here we have the large language model configuration options. Personica AI supports the integration of large language models through llama.cpp or llama.c++, which is an integration engine and integration server that is released under the MIT license. So it's able to be bundled with Personica and shipped in your final packaged game. Now, Personica supports Windows, macOS, and Linux operating systems. In the preferred backend, you're only going to see options specific to your operating system. So I'm using Windows in this case, so we have three different backend options here for Windows. Now, what this means is these are essentially three different versions of llama.c++ or llama.cpp. Each version has its own performance benefits and possibly its own drawbacks as well. So for example, as a Windows user, if I want to be sure that my final packaged game and the LLM integration is going to work across both NVIDIA and AMD graphics cards, I might want to use Vulkan because that's the cross-compatibility default for Windows. So I might want to build this game using Vulkan. If I know that I'm primarily targeting NVIDIA devices, if I'm doing something specifically that involves NVIDIA technology, I might want to choose CUDA instead. Now, CUDA is going to give you a bit of a performance boost if you are using a NVIDIA graphics card. but there might be some overall performance degradation on the rendering side. So that's something to keep in mind as you're using Personica. There's always going to be a bit of a balancing act between how quickly the LLM responds and how well it does with responding, how coherent it responds, and also the actual performance of the game. So you can't load a super large model and have Unreal Engine running at the same time. But maybe potentially using the CUDA backend, you can support a little bit larger models or less quantized models. And then the last option for Windows is our CPU fallback. So with Vulkan and CUDA, those versions of llama.cpp, they will load the large language model on the player's graphics card. So it will sort of be competing with the game for that video memory. If you choose to use the CPU only backend, the llama.cpp server will load the model on the player's CPU and also on your CPU as you're developing the game and testing the game. Now, this is going to be much slower than using the GPU, of course, but it's also going to be more reliable. The game performance as a whole is going to run a little bit better because ultimately you're not using the GPU for any kind of LLM inference. You're just using it to render the game. So the game as a whole might run a little bit smoother, but you're going to have much slower LLM response times. This CPU option might be really useful if you're only intending for LLM integration in the background, for characters or world mediators or world managers that you don't really care about the latency, right? If you can afford having a response time in the 10 tokens to 15 tokens a second area, then CPU might be the best option for you. Now, these are just, again, the Windows specific options. If you're on Linux, again, as of the publication of this video, you have the option between Vulkan and CPU. If you're on Mac, you just have the option right now of using the version of llama.c++ released for Apple Silicon. Of course, that's probably the best performing macOS version of llama.c++, and that's the one that we certainly recommend using. Also, something important to keep in mind is Personica includes automated fallback behavior for these different backends. So for instance, if you select the CUDA backend and you're working on an NVIDIA machine, you package the final product using this CUDA backend, it will still also package the Vulkan and the CPU backends as well. So if a player then downloads your final packaged game, if they don't have the CUDA specific files on their device that's needed to run that technology, the Personica engine will detect that and automatically fall back and launch the Vulkan version of the llama.c++ server instead. The same thing is true for Vulkan. So if your computer is the game developer, or if the player's machine does not have the ability to run either CUDA or Vulkan, then the Personica backend will automatically fall back to using the CPU option. This helps maintain continuity for the game, helps prevent any serious crashes or performance issues, ensures that the Llama server starts on all types of player machines, no matter how good their graphics card might be. Now, the same thing is true as well for Linux. Linux just has Vulkan and CPU, but there is automated fallback abilities there. In the custom server executable path, so if you have a specific version of llama.c++, or if you want to sort of jerry-rig your own custom server that uses sort of the same methodology as llama.c++, you can absolutely do that. All you'll do is add the actual path to the llama-server.exe or equivalent file in other operating systems to this field. The last setting here in that drop-down for local servers is enabling flash attention. So flash attention is basically a little bit of a technical power-up that you can choose to enable if you want better LLM performance on modern hardware. That also comes at the cost of using more video memory. So if you are using some of the GPU-based backends, this might degrade the overall rendering performance of the game if you have this enabled. So this is disabled by default, but if you want LLM models to run even faster, we recommend enabling this. Now moving into our different options for models. So Personica AI supports both local large language models using the llama.cpp server and gguf or gguf model files, and connections to cloud-based API providers for LLM inference. So we like to default a little bit towards being local. So here we have our default local settings. Typically you won't need to change these unless you know for sure that you have something operating on the same server URL or on the same server port as defined by default. Next is the specific model path to the actual gguf or .gguf model that you want to use as the large language model that you're integrating. This model path is going to be relative to your project's content folder. So here I have this project called tutorial project open. So if I navigate to tutorial project /contents /personica/models, I'll see this gemma-3-4b.gguf file in there. Now, if you're not super familiar with LLM files or with ggufs or with sort of local model terminology, this Gemma 3 label here, it's just basically what model it is. This 4b tag is the number of parameters. So if you're used to working in media, you can think of this as kind of being like resolution. It's basically like the number of reference points that the model has to use when comparing tokens and doing its underlying LLM math. The greater the number of parameters in this case. So if that number was higher, we might have better reasoning, but we might also have worse performance. So just keep that in mind. That's another part of that balancing act here. This IT tag stands for instruction tuned. So this specific model that we currently have bundled with Personica by default, it is tuned to give a little bit of extra weighting, consideration to any kinds of instructions where the user is directly prompting the LLM to do something. So that's a super useful type of model fine-tuning to have because the models will be more responsive to prompts that you send to it that says, act in this certain way, behave in this certain way, don't do this. This IT fine-tuning really helps. And then the last part is this Q4_K_M. What that stands for is the quantization of the model. And the easiest way to think of quantization is more or less to think of lossy compression. It's a way of getting a model to be smaller, to take up less space, but there might be a little bit of performance difference there compared to the fully unquantized model. Now there are different types of quantization. This Q4KM, that's just one type. You might see Q6 or Q8 or Q4_K_L. Take some time to experiment, take some time to learn what the differences between each are, and do your own experimentation and see which model is right for you. We really enjoyed the Gemma 3 4 billion instruction tune model that we currently have bundled here. We think it handles reasoning and writing really well for its size, but for your specific uses, you might want a smaller model that can process things even quicker, and the accuracy doesn't need to be quite as exact. Or you might need a larger model that can take in a lot of context, a lot of complex information, and it doesn't necessarily matter exactly how long it takes because you're designing the game purposefully where that latency will be masked a little bit. And then lastly, we have GPU offload layers. So this is the ability to fine-tune the actual launch command for the llama.cpp server backend. Here it's set to 99, and what that essentially means is by default, we try to offload all of the GPU's layers to the LLM to improve performance as much as possible. And we make some sacrifices in terms of game rendering and game sophistication to help facilitate that. Now, if you want a little bit more of a balanced approach, you're okay with the LLM running a little bit slower and the game running a little bit better, you can lower this value down to the exact number of GPU layers that you want to give to the LLM. Now, if you're interested in non-local uses for Personica AI, we do support those integrations as well. We have the 3 sort of flagship organization API models supported by default. So OpenAI with ChatGPT, Anthropic with Claude, and Google with Gemini. And each has the ability to set specific settings for each provider. So for instance, if I want a certain model from Anthropic, I can certainly set that up here in my configuration. Same thing goes for ChatGPT and Gemini as well. We also have a custom endpoint option. So if you do have a different provider or your own API-based system that you want to use, you absolutely can use it here. All you have to do is add the URL and the API key here. Be careful with maintaining your API keys as usual. We do try to keep this censored by default, so anything that you keep in there gets converted into asterisks, so it's a little bit harder to leak. Now, if you're not familiar with LLMs very much, a setting that you might not be super familiar with is temperature. And you can think of temperature as being kind of the variance or the variability of the word selection choice for the model. So for example, if I have a relatively low variance, that means that the model is going to tend to choose the most probable words more often. Whereas if I have a model with a relatively higher amount of variance, that model is going to choose some of the less probable words sometimes. So I have more variability in the language, more variability in the sort of reasoning, but I might also have a greater risk of hallucination or a greater risk of the model saying something that's sort of out of character or nonsensical. So this is really a setting that's worth experimentation and is really dependent on the actual model itself as well. Lots of different options for both local and cloud API LLM integration here. We're constantly looking to add more. If there's an option or an integration pathway that you're interested in but you don't see that available here, please get in contact with us because we want to make this as accessible as possible. Now, if you are using the Cloud API connection, one of these settings menus that I highly recommend checking out is the budget drop down. So here we have some of those fine-tuned controls to help make sure that you don't experience those runaway usage fees. We have several different sort of presets to select from. We do recommend, if you are going with local, to just go ahead and choose the local budget preset, even though some of these settings really won't matter with a local setup. We also have a custom setup as well if you want to set your own estimated cost in United States dollars per 1,000 tokens or so. Again, this is estimated, this is not exact, and this is also subject to change based on the actual usage fees of the chosen provider that you are using. So just keep that in mind. This might not be the firm number that you have. You can also restrict the number of API calls for every minute, as well as warn on high usage and even stop once you hit that API calls per minute there. So that really helps with preventing those runaway situations where you're making 10 calls to the LLM, but only one succeeds, only one comes back to the game, and now all of a sudden you spent 10 times the amount of usage fees for just one response. The next menu that I recommend checking out, regardless of if you're using Cloud API or local setups, is the optimization menu. If nothing else, to just get familiar with what you'll be seeing in the output log as you are starting to use Personica. So if you start a editing session or you launch to play an editor, if you have the server configured to start on the game startup, that will start a heartbeat health check. So every 2 seconds, Personica will ping llama.cpp and say, hey, are you operating? Are you up? If it does not, in this case, get a positive response back within 20 seconds, Personica assumes something's gone wrong with the server. Instead of me trying to launch this application on this computer over and over again, let's just kill it. We also have the ability to set a default request timeout. So once a request to the LLM is sent. This is how long in seconds the LLM has to return a response and mark that LLM call as complete. If not, it is marked as incomplete or failed, and then the retry system kicks in, which we'll get into in a later video. We also have the ability to toggle the silent warm-up. This is enabled by default. We recommend enabling this when using Personica. This goes ahead and loads the local model onto your local server so that the model is already up and running by the time you send the first actual player's request to it. Basically, this launches the model, loads it up like any other process with the model and the llama.cpp server, but there's a brief test prompt that is sent to the model, and once Personica gets a response back, it kills the rest of the response and says, all right, the model's already loaded up. Sounds good. Let's get moving with our future requests. And then we have the ability to set a global max wait queue size limit. So what that is the number of total requests that can be sent to the LLM and queued for the LLM in one time. So if there are, let's say, 20 characters, each with one request being sent to the LLM, that's going to not all be processed at once, but one by one. So that's a queue of 20 requests. And then if a 21st character comes along and makes a request, then that request is just outright refused, right? So then you can use fallback behavior there and just say, hey, the queue for the LLM, it's too long. Please go and do something else, right? Go and do some sort of hard scripted behavior. What I want to get into at the end of our video is just how do we add the actual Personica component to the game. So I'll go ahead and I'll add a new character. And we're just going to call this a test character. And opening our test character, let's go ahead and just assign our default Manny mesh. Rotate him around. And then if I want to actually add Personica integration to this character, all I have to do is go to the components menu, click add, and then if I have the Personica plugin installed, I can add the Personica brain component. I do recommend giving every character's brain component a unique name because you'll often be referencing the name, referencing the exact brain component in different blueprints. So just having a million different brain components that say brain component 0, brain component 1, that might be a little bit confusing. So here I'll just call it test character or test care brain component. And there we have it. I've added the brain component to Manny. Now I'm ready to begin setting up some of these specific character values and profiles here. So in future videos, we're going to go over how to set some of these data assets up, like the Personica profile and the Personica prompt templates. We're going to get into a little bit more blueprint build and in sending and receiving requests to and from Personica, and how to maybe display some of those requests in the game depending on whether you want to use our final interpretation pipeline or the expressor interpretation pipeline. So lots of different configuration options to get into and explore in future parts. Thank you so much for joining me today for part 1 of this. I hope that this introduction to Personica has been helpful. We will be releasing more video tutorials, so please like, subscribe, and hit the notification icon if you're interested in keeping in touch. Otherwise, if you have any questions, comments, or concerns, please reach out to us at contact@swamprabbit.labs.com or visit our website for additional information. My name's Chris Terry, and I hope you guys have a great day.